So we're going to go through systems of equations. They've given us two equations here. And it's good to get into the habit to number our equations, because as we go into this, we'll get more and more equations, and it can get very confusing on where we created one and what we started with. So we're going to talk about these ideas. These here, we have two major variables if we're talking about two space, right? It would be x and y. Our unknowns are going to be a and b in this question. X and y represent any point or any coordinate in two space. The three cases we can solve for, if these each represent a line or a vector, is case 1, which is an infinite number of solutions, 2 where there's none, and 3 where there's 1. If it's an infinite number of solutions, what are we looking at? We're looking at the same equation. So, with that being said, just by inspection, are we able to solve for b and a? If I'm looking for case 1, infinite number of solutions, what would, in case 1, a equal and b equal just by inspection? What would a be? 8, and b would be 4. Yes, we're going to be looking for identical equations. Okay? So in this case, a would be 8 and b would be 4. So we'd be looking at x is equal to 4, y equals 8, and, whoops, not equal, plus. X plus 4y equals 8. These are identical solutions. One of them could also be a scalar multiple, but because our x values, or the coefficients in front of our x, were both 1, we're looking for identical equations. So that would satisfy case 1. Okay? If we had an infinite number of solutions, a would be 8, b would be 4. Okay? Case 2, we're looking at 2 solutions. Oh, sorry, not 2 solutions. 0 solutions. It's case 2. 0 solution means what in 2 space if we have 2 vectors or 2 lines? What's that? They never touch, which is known as parallel. That's right. That means we have 2 lines or vectors that are parallel to each other, so they'll never cross each other. Now, thinking about your slope y-intercept form from way back in grade 9, what would that mean for our b in this question? If I'm looking at case 2, and maybe I should change it to slope y-intercept form for you. Okay. Case 2, we're looking at 2 parallel lines. So what I'm going to do is I'm going to set them both equal to y. Maybe this will make it a little clearer for you. So if we set them both equal to y, our equation 1 becomes 4y equals a minus x. Y equals a divided by 4 minus a quarter x. And equation 2 becomes by is equal to 8 minus x. Y is equal to 8 over b minus 1 over b x. Okay? So, if we need them to be parallel, we're looking at the coefficient in front of x. Okay? So specifically, the slope needs to be identical in both of them. So our b in this case needs to be what value? 4, that's right. So we know we need a b to be the value of 4. That way both of the slopes are the same. So let's incorporate that 4 and see where we end up with. We then have y is equal to, we still have an unknown for a, 4 minus quarter x. And y is equal to b divided by, 8 divided by 4 is 2, minus 1 over 4x. Okay, so our slopes are the same. Now, for a, we can have almost any number of solutions except for a very specific one. Anyone know what that very specific solution is? 8, that's right. We can't have it be 8, because if it is 8, then we're satisfying case 1 again, and we have identical solutions. For a can be anything except 8. Okay? So as long as b is 4, a can be any other number except 8. And that would satisfy 2 parallel lines. So they're not coincident. Okay. And finally, the third case here, we have 1 solution. So case 3. Okay. Case 3, we'll rewrite the 2 originals again. X plus 4y. 4y y equals a, and x plus by equals 8. Now, for case 3, I want you guys just keep in mind what we got as answers in the first two. In case 1, our answers were a equals 4 and b equals 8. Was that right? Case 2, a equals 4. No, sorry. I think I've written those backwards. Did I write those backwards? Let's look at the answers. A was 8. Sorry, there we go. A equals 8, B equals 4, B equals 4, A cannot equal 8. Okay? So for case 3, for points of intersection, we can have tons and tons of them. Any number, depending on what we put in for A and B. The only thing that's really going to stop us is if our B value is equal to 4 or A value is equal to 8. Okay? So specifically, we just have to make sure we don't end up with our same slope here. If we have varying slopes, then we can put any values in. So in this case, we don't even have to put a parameter on A. We just have to make sure that our B, in this case, put it in red, B cannot be equal to 4. Because if B is equal to 4, then we're dealing with the same slope. And if we have the same slope, then we either have parallel lines or identical lines. Our A value can pretty much be anything it wants because it doesn't affect the second equation here. So do you guys want me to put in the slope y-intercept so it looks a little clearer? Let's go back to our slope y-intercept. So equation 1, scroll up a bit, y was equal to a over 4 minus 1 over 4x. And equation 2, we had 8 divided by b, I think. Yeah. Minus 1 divided by b equals x. Okay, so the important part here is slope, like we talked about before. We just got to make sure the slopes aren't the same. If the slopes aren't the same, then we can have any number of solutions. So in order for that to happen, the only restriction we have is on our variable b. We just have to make sure b is not 4. If b is not 4, then a can be any number. In fact, it can be 8. It doesn't matter because the slopes are different. So the only restriction we have in this case is b cannot be the number 4.